Assalamu alaikum warahmatullahi wabarakatuh. We will talk about the work, lesson 1, unit 4. What's meant by work? If you want to push a wall, the wall will not move. So you make a force, pushing force, but the wall doesn't move. So there is no work. In physics, there are two conditions for work to be done. Number 1, an acting force. Number 2, a displacement in the direction of the force. And please take care from this, in the direction of the force. Like what? When you kick your football, you make force, and the football will move for distance or displacement. So there is work, because work needs two conditions, force and displacement, needs both of them together, not only one. Do you understand me? So if I want to determine the work by this relation, work equal F times D. Now the measuring unit of work is joule, and joule equivalent to what? Newton times meter. Newton force times meter displacement. Newton equals what? Kilogram meter per second square. Kilogram meter, and this meter, so will be kilogram meter square per second square. Dimensions of work, kilogram m, meter square L square, per second square T power negative 1. Please take care from this point. Work is a scalar quantity, not vector quantity, although force and displacement are vector. Due to we need the dot product, only the value of the work. Like, for example, the work done to move a cart 5 meters forward is the same as that to move the cart 5 meters backward. So we need to calculate the value, not the direction. What will happen if the direction of the force is inclined at an angle to the direction of displacement? Then work equal FD cosine theta. Please, if we have theta from first term, we say that take care, theta between what and what? Theta between force and the direction of displacement. Open your book page 117, example number 1. A card is pulled by a force of 50 Newton. The line of action of force makes an angle 60 to the direction of displacement. So he gives me that 60 between force and displacement. So we can use it in our rule for 4 meters. So F 50, D 4, cosine 60. Do you understand me? Please take care. Theta between what and what? Now, like this, if I have force by green color, make angle theta with the direction of displacement. This object moves from left to right, so the direction of displacement from left to right. So we need F cosine theta, not F sine theta. Do you remember resolution of force into x-axis F cosine theta and y-axis F sine theta? We deal with what? We deal with F cosine theta. Why F cosine theta? Due to the direction of what? Direction of displacement. Do you understand? Now, the factors that affect the work from rule. Number 1 is the acting force, directly proportional, and the graph will be straight line passes by the origin point. When get slope work over force equal D cosine theta. Number 2, the displacement of body, directly proportional. Also, straight line passes by the origin point. slope work over displacement equal F cosine theta. Number 3, cosine. Cosine what? The angle between, take care, between what and what? The force and the displacement. Directly proportional. And directly proportional, straight line passes by the origin point. Work over cosine theta equal FD. Now, types of work. We have 2 types. Number 1, negative work. Number 2, positive work. What's the difference between them? Positive work, it is normal work when the force and displacement are the same direction. Do you remember this point at the beginning? Displacement in the direction of force. But negative work, displacement in the opposite direction of the force. Like what? Like friction. Friction force, it is the opposite direction for displacement. So here, negative work. Do you understand? And we can know the negative work and positive work from the sign. How from the sign? If theta equal 180, cosine theta will be negative 1. If theta bigger than 90 till 180, its sign will negative. So we can know that we have negative work. Like, for example, if you have picture in the exam, this is negative work or positive work, we can determine from the arrow of direction. Arrow of direction of displacement to right. Arrow of direction of force to left. So both of them opposite. So it's a negative work. Here, displacement to right, force to left, opposite direction, negative work. What about positive work? If theta equals 0, cosine theta will be 1. And any angle between 0 and smaller than 90 give us positive. Cosine 60, cosine 70, try by your calculator. In this point, we will get positive work. From picture to can determine the negative and the positive. Number 1, like this. Direction of displacement. This box will move from left to right. And man, try to pull it from left to right. Both of them the same direction of arrow. So, positive work. Number 2, arrow of force and arrow of displacement. So, positive work. Now, what will happen if the force perpendicular on displacement? What will happen? Normal force on displacement, theta equal 90. We know that theta equal 90, cosine theta equal 0. So there is no work, no work. And please take care from this point, like this. Displacement, direction of arrow of displacement, what? From right to left, from right to left. But the direction of force perpendicular to the displacement. So here no work. Like when you carry your bag. You carry your bag like this, force up. And when you move, the direction will be horizontal, perpendicular. So there is no work. An important idea, satellite and circular motion, the force is perpendicular, so no work. Please take care from this. Centripetal force in circular motion towards the center, and it is perpendicular, it is normal to the direction. So there is no work. Please open page number 124, number 7. The arrow in each figure shows the direction of the acting force. Which of these figures shows that there is a work done by this force? Give reason for your answer. Number A. Number A, he sits on the chair. And the force, it is the weight, downward. So no work. Why no work? because there is no displacement. Two conditions to make work. Number one, force. Number two, displacement. B, yes, B, there is work. Displacement and the direction of force, so there is work. Number C, work also. Direction of force and displacement. Number D, it is a satellite and force perpendicular, so there is no work. Now, example number 2, page 117. Calculate the work done by a girl, okay, on a bucket of mass 300 gram. So 300 gram divided 1000 to convert it into kilogram. That is carried by her through a displacement of 10 meters in the horizontal direction. Excellent. This is like your bag. You carry your bag. She carries the bucket. So the force will be up. Excellent. And moves horizontal. So the force will be perpendicular to the displacement. There is no work. Okay. And the boy, calculate the work done by a boy to lift a bucket of a same mass through a displacement of 10 centimeter. Take care, 10 centimeter divided 100 to convert it into meter. In the vertical direction. So, in the vertical direction, the force will be up and the displacement will be up. Both of them in the same direction. So, angle theta will be 0. Excellent. So, work equal FD cosine theta. We will get the work. And take care, force here will be the weight, mg. Do you understand? Gear carries it a horizontal, but boy lift it vertical. Take care from this. If you carry anything and move horizontal, no work. But if carry thing and move vertical, there is work. Do you understand? Now, we will compare between two cases. Number one on pushing, number two on dragging. Number one, if you push this bag, its weight affected towards the down and your force inclined by angle theta. If you make resolution to force into F cosine theta and F sine theta here will be down by the same direction of weight. So, if the same direction of weight will increase friction, so you need more work. Do you understand? And the same idea here, but force towards up. So F sine theta will be up. Do you understand the difference? F here, look, or the arrow to down. So F sine theta will down with weight, but here, arrow of force up. So F sine theta to up in the opposite direction of weight. So decreases friction, less work is required to move the object. Okay? Now, special case example number 4, page 118. Special case. A worker that carries a box of mass 40 kilogram climbs up stairs of length 20 meter as shown in the figure. If the free fall acceleration 10 meter per second square, find the work done on the box. Okay, this is stairs and this is the direction of motion. We have the theta between what and what? We have the theta between displacement and the horizontal. But we know that theta, the angle between displacement and force. So theta will be 60, not 30. This is 90. So if I have this 30, so this part will be 60. Please take care. Theta between force and displacement, not displacement and horizontal. Okay? Force here, it is the weight, mg, and work equal FD cosine 60. And finding work done graphically if I have graph FD, the work will be the area below the curve. Do you remember area below the curve? Do you remember we studied it at first term? And example number 5, page 119, please try to answer it by yourself. Thank you very much.